Okay, so this is now the 15th video of this booklet. We are on page 15. Okay. Again, people, at this point you have to first do the diagram, work through it, study the diagram, try as far as you can to solve it before you go and watch the solution to the video, to the question. Okay. Firstly, we are told that we read through all of this already. So we established that we're going to calculate angle A first. So we know that angle A1 is equal to A2 is given. Or we can first say that BAT is equal to 60 degrees. That is opposite angles equal in parallelogram. Opposite angles are equal in a palm. So that's going to give you 60 degrees. So it's 30 and 30. So now we're going to say that A1 is equal to A2, which is equal to 30 degrees. Why? Because it's given that AE bisects DAB. Okay, so that's given equal there. So there's 30 degrees. So D1 is also going to be 30 degrees. Why? Because it is angles opposite equal sides. Okay, as you can see, that is given equally. Okay, so now I can work out E2, how? Sum of triangles. E2 is equal to 180 minus 30, which is 120 degrees. The reason there is sum of triangles, that is triangle ADE. Okay, so that's 120 degrees. So then E3, as we said, is going to be a revolution. So angle E3 is now number 1. E3 is equal to 360 minus 120, which is 240, minus 90, which is 150 degrees. And then 50 degrees. Okay, and the reason is revolution or angles around a point. Okay, so that is going to be 150. Alright, so let's look at number 2 and change our color. The question says calculate to solve for x. As you can see here, there's a four-sided figure, so that's the interior angles of a quad. It will add up to 360 degrees. So it's going to be 3x plus 30 plus 150 plus 2x plus 20 plus 60 equals 360. That is your interior angle of quad. Okay, so it's 5x plus, that's 50, 110 equals 360. Let's check. 150 plus 60 plus, no, that is not right. It's going to be 5x plus is 30 plus 150 plus 20 plus 60 gives you 260. So it's going to give you an answer of 100 degrees. So it's 360 minus 260 should be 100 divided by 5. Divided by 5 is going to give you 20 degrees for x. Okay, so x is equal to 20 degrees. In number 3, it says prove that D2 is 90 degrees. So D2 is 90. How do we do that? By as you can see, D2 is going to be, here's the color here. So angle D2 is going to be 3x, which is 3 times 30, or 20, sorry, x is 20, plus 30, which gives you 60 plus 30, which is 90. Okay? So they have just proven, therefore D2 is equal to 90 degrees. I didn't have to write that there. But we just proven then now that D2 is 90 degrees. Okay. Sorry about that miss again. Right, now we're looking at page 16. It says, for each pair of triangles, state the case of congruency. So at this point you were exposed to the 4 cases of congruency. Is side, angle, side, angle, angle, side, 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 and right hand hypotenuse side. For this one here, for that case of congruency, the angle must be the included angle here. Okay, so what does that mean? If I know that side and this side and I'm using an angle, it must be that the angle, the inclusive angle. Okay. So in the first case here, as you can see, the 5 is equal to 5. That angle is equal and that is equal. So what's the case for congruency here? It's going to be side angle side. As you can see, it's an included angle there. If you look here, that side 52, 52, 39, 39, right? And the case for congruency here is going to be side, side, side. So we know the three sides are equal. This one here, we are using the right angle, we are using the 90 degrees. We know the hypotenuse and we have another side. So this is the case of right hand hypotenuse side. So RHS. Okay. The next one. If they'd ask you for the triangle and the order as well, we could have given that as well. So here you could have said triangle CAB. No, you don't need that. Is congruent to triangle FDE. And what's the reason there? That would have been the reason there. Here it would have been triangle ECD is congruent to triangle. So here is your 39. So I'm going to go through the 39 first, which is BCA. And that would have been side, side, side. Okay, but you'll see how we use it very soon. Here we have an angle in the side. So here we can just say angle side. So use two angles in the side. Okay, these videos are free. If I made any errors, please let me know on that number. And then the last one here we have that side, an angle and an angle. Okay, how do we know it's angle? So that is vertically opposite there, and that's alternate there. Okay. As we said, they didn't ask us to prove congruency, just wanted to know the case. So yeah, it's also angle side. Okay. So that is page 16. So we're going to page 17. In page 17, it says, show that the following triangles are congruent. Use your knowledge above the properties of triangles and make use of congruency notation. Okay, so I have indicated already that that is your sign for congruency, mathematical notation for congruency. Okay, so what we need to do here is, when we're proving that triangles are congruent, okay, so we either prove that the case of side, side, side is evident, we prove that the case of side angled side is evident, your RHS, or angle side. Okay, so those are the four cases for congruency. Okay, again, this one here, your included angle needs to be the known angle there for two sides in an angle. So looking here, we're going to first state which sides or which are equal. So we name the triangle, we say in triangle ACB and triangle FTE. Okay, so what can we say? See, there's 45 and 45. So we say angle A is equal to angle D, which is equal to 45. And what's your reason there? Given. Okay, as you can see, it's on the diagram, so it's given. Then we know that CB is equal to FE. How do we know this is equal to that? It's also given to us. Okay, then we know that angle B is equal to angle D. Sorry, angle B is equal to angle EY, also given to us. Alright, so we can conclude therefore triangle C or ACB is congruent. So now the order is important here. So it's going through the 5, then the 6. So we must go through the 5 and then the 6. So it's congruent to triangle FDE. And what's the case for congruency here? And to be used two angles in the side. Okay. We'll carry on in the next video.